Today we are talking about how we can turn fractions into decimals. So a couple quick reminders. One of the biggest reminders is that every fraction represents a division problem. We have been talking about that since the beginning of the year when we talked about unit rates and ratios. So that's what we're going to be thinking of them as division, which means we can turn any fraction into a decimal by doing long division. So we're going to be practicing that a lot today. Couple new things. One of the things you might encounter is if you have to divide with 0, or 0 might be in a fraction. If we ever have 0 divided by any number at all, positive, negative, fraction, decimal, whole number, if you have 0 divided by something, the answer is going to be 0. However, if you have it the other way around, where you have any number divided by 0, your answer is going to be undefined. Those are just kind of some basic rules you're going to need to remember. Basically, with dividing 0 by any number, you can take 0 things and split it into groups. There's just going to be 0 things in a group. You just cannot take 11 items and split it into 0 groups. There is at least going to be one group of 11. It's going to be impossible to split it into 0 groups because you at least have the one group of 11. That impossible fact is where we use the phrase undefined. We're also talking about the different types of decimals that we could encounter. So a terminating decimal is one that ends or stops, or it has 0 for a remainder. So like 5, any whole number is a terminating decimal. Or 2.67, that's a terminating decimal. So anything that ends or it has 0 for a remainder. Decimals that continue in a pattern forever are repeating decimals. So they keep going on and on and on forever, but this is a pattern that you can predict. And finally, non-repeating numbers go on and on and on forever, but there is no pattern. We also call these irrational numbers. So one of the things we're going to practice a little bit is just recognizing writing repeating decimals. So again, they're never going to end, so they are not going to terminate in 0. Instead, they're going to continue in some type of pattern. And this pattern can be shown with the 3 dots or with a repeating bar. The repeating bar is what we're going to practice writing with. So in these examples below, we're going to put the bar over the correct numbers. We always want to put the bar over the numbers that repeat and only the numbers that repeat. So in this first example, we have 0.123, 123, 123, and the dots show that it keeps going. That means when I add the bar in, it's the 1, 2, and 3 that I'll repeat. Therefore, the bar goes over all 3 of them. In my next example, I have 5.6, 22222, and so on. In this particular number, only the 2 repeats. So when I add my repeating bar, it should go only above the 2. In the third problem, 7.11, 45454545, and so on. In this problem, the only thing that repeats is the 4 and the 5. So the line goes over both 4 and 5, but nothing else. Finally, we have negative 1.050505, and so on. In this problem, it is the 0 and the 5 that repeat, so the line goes over both of those. Again, only use the repeating bar over the numbers that repeat, no more, no less. Next, we're going to talk about how we can identify whether they're repeating or non-repeating. I'm actually going to have you cross that out, and it should be terminating here. I didn't include any non-repeating numbers in this list. It's just either repeating or terminating. So in the very first number, I have negative 4.19999, and then there's a line over the 9. That line, or in other words called a repeating bar, tells me that that's a repeating decimal. 0.2. It stops. It doesn't continue. There is no pattern. Therefore, it's terminating. 18.35, again, it stops. There's no continuation, there's no pattern. It is terminating as well. Negative 8.4, and the 6 has the bar over it. That's 6 with the bar over it tells me it keeps going, therefore it repeats. 0.36 in the bar over both of them, that tells me that both the 3 and the 6 repeat. On the back, we're going to actually practice turning fractions into decimals. So we're going to be doing a little bit more math with these. In order to do this, if necessary, we're going to turn any mixed numbers into an improper fraction. Since we're dealing with division and we're dealing with fractions, you know we cannot do division unless it's improper. Then we're going to set up long division, where the top number always goes on the inside or underneath. Does not matter if it's bigger or smaller. It's all about the order. Order matters when we divide. So the top number of our fraction goes on the inside and the bottom number goes on the outside. Then we're going to continue with our long division until either we have a number that terminates in zeros or we notice a pattern. One of the things that we're looking for as far as establishing a pattern is that we are going to be continuously getting the same remainder over and over again. All right, so we've got a couple examples here. We're going to start with the first one, 1/5. Because I need to set up long division, I'm going to write my long division bar. My top number goes on the inside, my bottom on the outside. And since I know that I'm turning this into a decimal, I'm going to go ahead and add a decimal at the back and a 0 so I know that I can keep going. All right, so 5 cannot go into 1 or it goes in 0 times, and I want to mention that or write that down. But 5 can go into 10 and it goes in 2 times. 5 times 2 is 10, so when we subtract, I get 0 left over. Since I have 0 for my remainder and no other numbers to bring down, I know that the 1/5 is equivalent to 0.2, or 1/5 is a decimal, 0.2. That is a terminating decimal. In the second problem, I have 5 and 2/9. I first need to make that improper. 9 times 5 is 45, plus 2 is 47 over 9. When I set up long division, top number on the inside, bottom number on the outside, I'm going to add a decimal and a 0 that I will need to use later on. All right, 9 cannot go into 4, but it can go into 47 5 times. When I subtract, I get 2 left over. Bring down your next digit. 9 can go into 20 2 times. With 2 left over, add a 0 to bring down so you can continue. 9 can go into 20 2 times. With 2 left over. And if you added another 0 to bring down, you would notice a pattern. We are continuously getting this remainder of 2 and saying that it goes into 22 times. That means that I have a repeating decimal. I've established a pattern. And my answer to this one is going to be 5.2, and the 2 repeats. So I need the repeating bar over the 2. If you notice that whole number and that decimal, the 5 is a whole number in both. In future problems, if you want to go ahead and write your whole number in fraction form as the whole number in the decimal and just worry about dividing your numerator and denominator, you can do that. Or you can continue to make it improper like I did in this problem. Moving on to the next one, I have 6 over 16. 6 on the inside, 16 on the outside. I'm going to add a decimal and a 0 to keep going. 16 cannot go into 6. I'm going to say it goes in 0 times, but it can go into 60. You could round that 16 to either a 15 or a 20 to give you a good idea, but it is going to go in 3 times, and 16 times 3 is 48. When I subtract it, I get 12 left over. I'm going to add a 0 to bring down. Again, I could count up by 15s or count up by 20s to get an idea about how many times it's going to go in. But to go into 120, it is going to end up going in it goes in 7 times with 8 left over. Since I still have a remainder and I don't have a pattern yet, I'm going to add another 0, bring it down. 16 can go into 80 exactly 5 times with nothing left over. 0 for my remainder, nothing else to bring down. That means I'm done. My answer to this problem is 0.375. It's a terminating decimal on this one. Last 3 examples. I have 1/6, top number on the inside, bottom number on the outside, add a decimal and a 0 so we can continue. 6 cannot go into 1, so I say it goes in 0 times, but it can go into 10 1 time. When I subtract, I get 4 left over, add a 0 to bring down. 6 can go into 40 6 times with 4 left over. Add a 0 to bring down. 6 can go into 40 again 6 times with 4 left over. And if I were to add another 0 and bring it down, I would be asking again how many times that would go into 40. At this point, I've kind of established a pattern. I know that I'm going to continuously get the same exact remainder every time. So 1/6 as a decimal is 0.16, and the only number that repeats is the 6, so the line goes over the 6 only. The line does not go over the 1. The 1 did not repeat. For 3 and 1/8, again, you could say, I know my decimal is going to be 3 point something because that's my whole number. Or I could make that improper. 8 times 3 is 24, plus 1 is 25 over 8. Top number on the inside, bottom number on the outside, add a decimal and a 0. Again, 8 goes into 25 3 times, which we already kind of established with 1 left over. Bring down your next digit. 8 goes into 10 1 time with 2 left over. Add a 0 to bring down. 8 goes into 20 2 times with 4 left over. I still don't have a pattern. I still have a remainder, so I'm going to add 0 again to bring it down. 8 goes into 40 exactly 5 times with nothing left over. That means I'm done. I can look back at the top of my division there to see my answer. It is 3.125. That is 3 and 1/8 as a decimal. And the very last one, I have 17 over 33. Top number on the inside, bottom number on the outside. I'm adding a decimal and a 0. 33 cannot go into 17, so it goes in 0 times. But 33 can go into 170. I would probably round that 33 to a 30 so I can do some easy and quick multiplication. 30, 60, 90, and continue counting up. What you would find is that it does go in 5 times. And 33 times 5, if you worked it out off to the side, you get 165. When you subtract, you get 5 left over. Since I still have a remainder, I'm bringing down a 0. 33 can go into 50 1 time. And when I subtract, I get 17 left over. Add a 0 to bring down. 33 can go into 170. We already did this. We know it goes in 5 times with 5 left over. If I bring down another 0, I would again be asking how many times into 50. We've established a pattern here. I know 33 goes into 50 1 time. I know if I subtract, I'm going to get 17 left over, and I would bring down another 0 to make it 170. This is my pattern. 2 numbers repeat in this one. The 5 and the 1 continuously repeat. That is the order I want to write it in. I don't want to mix up my order. I don't want to add another 5 at the end and draw a line over all 3 of them. There are 2 numbers that repeat, and I only want to write those 2 numbers with the line over them. Make sure you check in these notes with your teacher and ask any questions if you have them.